All right, this is lesson 7.3, graphing the cotangent, secant, and cosecant functions. We're going to start off with looking at the cotangent function. Cotangent function is basically the inverse of the tangent function. So tangent was sine over cosine, and now we're going to be cosine over sine. Remember, in the tangent function, we had asymptotes where the cosine function equals 0. And so, in other words, pi over 2 or negative pi over 2, etc. But now we're going to be looking at the areas where sine of x equals 0, and that's where our asymptotes are going to occur. And of course, that occurs when sine equals 0, where x equals 0 or pi. And so we have a period of pi again. So 0, pi, 2 pi, etc. Those are going to be where our vertical asymptotes occur. All right, so looking at the function of cotangent, again, it helps to write out the values of the cosine and sine at some of our key points, okay? And those are written right here. And so cotangent is just going to be the fraction. Remember, it's cosine over sine. So at this point here, because sine is 0, I'm undefined. And I went ahead to save some time and populated the rest of this. And so those are our fraction points, if you will. And so we have a vertical asymptote that occurs at 0, again at pi, and 2 pi. And so if I put in just one period's worth of those, I'm at 0 and pi. And I'm cross the axis at pi over 2. That's this point right here. And again, instead of going up and to the right this time, I'm going up and to the left. And that's the nature of the cotangent function, is it's the inverse or opposite of the tangent function. So when I sketch these then, my solution is to locate the two vertical asymptotes, just like I did with the tangent function. And I do that by taking the b value. In this case here, b is 1/3, right? Because it's x over 3. And so x over 3 equals 0, and x over 3 equals pi. And I'm going to solve those two for my x values. And so I have my first vertical asymptote occurs at x equals 0, and my second asymptote occurs at 3 pi, okay, because multiply both sides by 3. So now I'm going to find those points. I'm going to go ahead and plot those asymptotes in here. And again, I'm going to mark that as this is 0, and this is at 3 pi. So halfway between the two, right here, is that midline point. It's 3 pi over 2, right? Just dividing this by 2. So this is 3 pi over 2. That's my reflection point. Now I could plot a couple of other points in here if I wanted to do that. All right, so this would be halfway again in between those two. 9 pi over 4 right here. And halfway between these two is 3 pi over 4. And so now my cotangent function here, again, we know that x equals 0 is undefined and x equals 3 pi is undefined. We plotted those points on purpose. And our midpoint was our 0 point. Now, this function is stretched by 2. So at 3 pi over 4, I would normally be up at 1. But because I have this stretch, this point right here, we're going to call that 2. Okay, so that's 2 and negative 2. And so over here, I'm at negative 2. And always I'm going to start kind of going along the edge of my asymptote, curve over to my reflection, and then the s switches direction, and I'm back down here. Okay, so that's how we plot the cotangent function. One more example in here. Now I've got some other stuff going on. Again, I'm going to start off. I have a shift, right? I have a phase shift, and it's x minus pi over 2. So I'm shifting to the right pi over 2. And let's see if I've got those graphed in here already. Okay, so the first thing I do is I'm going to find that my two endpoints, right? So I would normally be x equals 0, but now I'm going to shift it to the right 1/2, right? So to get to 0, x minus pi over 2 equals 0, so x equals pi over 2. That's my starting point, or my 0 point. And then my other point here to get to x equals pi, so x minus pi over 2 equals pi. So again, I'm going to add pi over 2 to both sides, and so x equals 3 pi over 2. So those are my 2 points that I'm starting with for my asymptotes in here. This is pi over 2. Oh, I still, okay. So right here, I'm at pi over 2. And this is 3 pi over 2. So my midline point between these two is going to be pi. And I could go halfway again. This would be 3 pi over 4. And this one here would be, let's see, that's going to be 5 pi over 4. Okay, so let's plot some other points. I've got a shift up of 2, so basically we're going to multiply these values. So this one here is usually my 0. This is going to go up to positive 2. And this is going to go down to negative 2 here. So again, my graph is going to look very similar to the last one. The only thing you have over here is a phase shift to the right, pi over 2. Okay, x minus that. Now, don't let these intimidate you. The graphs of the cosecant and secant function, basically what we're going to do is just start by graphing either the sine or cosine function. And then from that, we're going to build on it. So remember that the cosecant and secant are the inverses of their trig functions. So cosecant is 1 over sine, secant is 1 over cosine. And so yet again, we're going to have a period where we're undefined. We're going to have vertical asymptotes where sine equals x and where cosine equals x. So for the secant function, I think we're doing, no, cosecant first here. Your range is from negative infinity to 1. Now, this is for the parent function, right? If this is a is going to change, okay, that's a possibility. So my range, remember, I'm going up to here to whatever this peak is here. And then I'm in union with whatever this point is here. And the parent function, these are both 1 and negative 1, right? So whatever the amplitude of my sine function is going to be my starting point here for my cosecant function. Period is 2 pi. We never cross the y-axis. There's no y-intercepts, of course. And my vertical asymptotes are in a period of pi. Okay, so this is, again, each of these vertical asymptotes hit at pi intervals. Okay, so we have 2 asymptotes per period. It's an odd function with a symmetrical about the origin. The secant function is the inverse of cosine. And just like that, again, the amplitude of the cosine function is going to be my max and min, respectively, for the two sets that make up our range. Period is 2 pi again. I do have a y-intercept in this case because, again, the cosine function starts here at y equals 1. And so my secant function is going to have that value here, and I'm symmetrical about that. And so the secant function is an even function, okay, with y-axis symmetry. So some of the properties of these two functions, we sketch the graph of the secant or cosecant function. We make a sketch of its reciprocal first. So if I'm going to do cosecant, first thing I'm going to do is do a graph of sine and build off of that. So the graph of the cosecant function, consider that. To graph cosecant, we know that cosecant is 1 over sine. So we can use that to help us identify the graph. And the graph of y sine is shown on the next slide. And we use this graph to help us to create the graph of cosecant. So we select our x values, find the sine of x for each value, find the inverse of each value, which is the cosecant. So the graph of the cosecant function here, this is started off with the graph of sine. Okay, so the sine is given below. And then I think I've got this populated here. No, I do not. Okay, so sine starts here at 0. When sine is 0, our inverse of that, our 1 over sine, is undefined. So we put a u here for that. That's why I have a vertical asymptote right here at x equals 0. So then moving on, for pi over 6, I'm at 1/2. So here I'm going to be 2. Pi over 3, I'm at radical 3 over 2. And so the inverse of that is 2 over radical 3. At pi over 2, I'm 1. And so the inverse of 1, of course, is 1. And this is the point where these two graphs actually touch each other. When I start going back down again here I'm at negative. Let's see, sine is positive here. So I'm positive radical 3 over 2 again. So 2 over radical 3. And just continuing on to 1/2 and 2. Undefined. And then negative values from here. So negative 1/2, negative 2, negative radical 3 over 2, negative 2 over radical 3. 1 and 1, negative 1, sorry, negative 1 and negative 1. Negative radical 3 over 2 and negative 2 over radical 3. And finally, negative 1/2 again, and negative 2, and then back to being undefined. So putting those values in here, again, I have my undefineds already plotted out at 0, pi, and 2 pi. This midpoint right here at pi over 2, let's just put that in real quick. I'm at 1, and my cosecant is also 1. So they're both values are right here. Now at pi over 4, my sine value is at 1/2, right? That's right here, right about, that's 1/2. But my cosecant is the opposite of that, so it's way up here at 2. Same thing at 3 over, on this side over here, I'm also at, and this would be pi over 3, pi over 2, 3 pi over 2, which is 2 over radical 3. And then finally here I'm at 1/2 again. That is at 5 pi over 6. I'm back up to 2 again. And so as I plot this graph, it's going to actually kind of look like this. I'm going up to the asymptotes. And so to plot these, now you see the same thing on the negative side. I'm not going to plot all these points. All I really need is this point right here. And the amplitude's good to know. So I find these two halfway points here and here. That's where I should be at 1, or -1 in that case. But since this is an amplitude, I'm sorry, this would be at 2, right? Because this is the 1. It's the inverse of 1/2. So I'm going to be going down this way. So again, once you plot the sine function, find your asymptotes. Drawing the rest of these, you just start here at the vertex is right here at the top of your arc, your max amplitude point, and you're going to curve up towards your two asymptotes. So the secant function is very similar. It's the inverse of the cosine function. And so again, I've already got the cosine function plotted. So at negative pi, I'm at -1. And so my secant is also going to be -1. At 1/2, I'm at 0, right? And so at -1/2, this is 0. 1 over 0 is undefined. So that's my first asymptote. When x equals 0, my cosine function is 1. And so this is +1. At 1/2, I'm back to 0 again. And so we're undefined. Pi is -1 and -1. And finally, back to 0 and undefined. And 2 pi is up at 1 and 1 again. So putting my asymptotes in here, my asymptotes are where I'm undefined. So I should also have one right here at -1/2 pi, if you will. And then my max values, this are the points where I meet right here. Okay, and so from here I could graph up towards my asymptote like this. If you have a stretch or compression vertically in here, remember that's not an amplitude for these. Okay, what you're looking at is this point right here at pi over 4. This value would be the inverse of this. This is normally 1/2, so this would be at 2. Okay, same thing on this side. You need to be aware that if you have a vertical stretch, that these angles are going to get steeper faster as we go. Now, typically you only need to do 1 period or 2, so 2 pi value for this. You don't need all 3 of these. That's why I only had 2 originally. Okay, so I'm going to graph the corresponding sine or cosine function. And then I'm going to draw the vertical asymptotes. And then those are the points where we cross the midline, all right? Not necessarily 0, because if I have a vertical shift up or down, it's where I cross that midline, right? That adjusted 0 value, if you will. And then finally, draw the secant or cosecant graph off of the minimums and maximums of the sine and cosine graph. First example here, I've got secant 2x plus 1. And so secant remember that secant is 1 over cosine. So I'm going to start this off by graphing the cosine function. And to do that, I find the period first. Remember, period equals 2 pi over b. In this case here, b equals 2, right? 2 here. So my period equals pi. So I'm just going to be scrunching everything up, right? They have a horizontal compression of 2. So if I have my x value And my cosine 2x, let's just do that first. And there's a reason behind my madness here, if you will. So my cosine 2x. So I start at 0. Cosine of 2x is 2 times 0 is 0. So cosine of 0 is 1. Remember, that's the x value, right? So that's 1. And then my next inflection point would be at where I'm 1/2, right? And so that point would be 1/4 of this. And so this is going to be pi over 4. So at pi over 4, if I put pi over 4 into this function here, times 2, it becomes pi over 2, which is 90 degrees, right, straight up. And at that point, my cosine is now 0, right, because my y value, or my x value is 0. So I'm 1, 0 here, and then at pi over 2, that would be the same as pi, and so at that point I'm at -1, and then this would be 3 pi over 4. I'm back to 0 again. And then finally, to close it out, I'm at pi, would be a full period, so I'm back to +1. So let's put some, okay, so now remember I have this vertical shift of 1, so that would look like this. I would just add 1 to everything here. So this becomes 2, 1, 0, 1, and 2. And this technique here helps me remember this, because now when I go to the secant function, I'm looking at this cosine row here for where I'm undefined. Because if I'm undefined here, it doesn't matter what I add to an undefined values, right? So the 2 doesn't really matter. It's whether or not this value is undefined. So this is doesn't change. And so these values stay the same. So I'm at 1 here, or 2, excuse me. At here I'm undefined, right? Here is where I'm at 0. I'm also undefined here at 3 pi over 4, so that's also undefined. Here at -1, and so I'm worried about this value. I'm going to go 0 here is my minimum, and then my max is back to 2. So putting in some asymptotes, and I put more in here than I really need, but let's go ahead and put those on my graph. So again, I'm at 0, and then this point is pi over 4. I'm sorry, this is my next asymptote, right? So this asymptote here is at 3 pi. Okay, this is 0, so this is pi over 4. And then I'm next undefined at 3 pi over 4. And then my next point here would be at, this is pi. And the midpoint right here is the other point we identified as pi over 2. Okay. So at 0, we already decided my cosine function is 2. So let's do, yeah, we'll do this as 2 here. Well, this is 1, and this is 2. And then -1 and -2. So I'm at 2 here, and then down to 0. No, down to 1 at pi over 4, I'm 0. That's right. So I'm at 0 here, but it's actually 1. And then down to 0, back up to 1, and then to 2. Okay, so my cosine function looks like this. And let's go ahead and use a different color for my cosecant. And my cosecant is going to go from these peaks right here. Remember, that's why this is 2, up this way here. And from this point, it's 0 down this way. From here, I'd go back up again like that, and it just starts to repeat itself. Okay, so that is the secant 2x plus 1. Next example is the cosecant x minus pi over 2. So again, I have this is the inverse of the sine function. My period is 2 pi. That didn't change on this one. Let's say I'm reflected. And I have a shift to the right, pi over 2. Okay, so with that information in here, I can start off by setting up my table again. So I have my x values and my sine of x minus pi over 2. So starting here at 0, if I put a 0 in here, I get negative pi over 2. And so sine of negative pi over 2 so sine of 0 would, and then I'm 0 minus pi over 2, right? So sine of negative pi over 2 is going to be negative 1. And then I'm at a normal interval in here, so I'm going to go with pi over 2 next. So that would be 0. Sine of 0 is 0. My next stop would be at pi. And here I'm going to be at positive 1, right? Because that's pi minus pi over 2 is 1. And then 3 pi over 2, I'm back to 0 again. And let's just complete this by going to 2 pi, which is 3 pi over 2, which is back to negative 1 again. Now, remember that this is reflected, right? So I'm going to go ahead and do that reflection right now. All right, so negative. And so everything here that's positive becomes negative. The zeros don't change, right? So this is now positive 1, 0, negative 1, 0, and positive 1 again. So my cosecant values then is still going to be 1, but now I'm undefined at 0, and I was undefined from this 0 here. Negative 1, undefined, and positive 1. All right, there are my cosecant values. Putting in my asymptotes again, and again, I'm undefined here at, this is pi over 2. And my next point at 3 pi over 2. This would be 5 pi over 2 if I needed it, or negative pi over 2 on this side. And okay, so where am I at when I'm at 0? I'm at positive 1, right? So let's call this point here 1. This is going to be 2. So I'm right here at 1. And then I'm at 0 at pi over 2. Negative 1 at pi, which is right here in between. Back to 0, and then up to 1 again here. So this is my phase shifted sine function. Like that. So putting in now my cosecant function, I use those as my starting points, right? And so my cosecant function is going to shift, right? This is my vertex point here going up, this point going down, and this point going back up again. Now, just for giggles, I'm going to take a second here and show you this in Desmos and what this looks like here. So I put in the negative sine x minus 2 pi already here. And that's this red function. So if I put the same function in here as negative cosecant x minus, and then that's pi over 2. You can see here, let's change the color of this if I could. No, I'll just leave it. Right here, this is those apex points, right? Where in here we're flexing up. And then these will be our vertical asymptotes right here. Remember that's where my where my sine function equals 0. Unfortunately, these don't give me that value in terms of, there it is, pi over 2. So yeah, there's my vertical asymptote of pi over 2 and negative pi over 2 over here, 3 pi over 2, right where my sine function equals 0. Okay. And I think I got one more example to show you in here. And so in this one, I've got, yeah, I'm stretched by 2, and my b value is 1/2, and I have a full shift of pi and a vertical transformation down -1. It's a lot to unpack in this particular problem in here. And so the easiest thing to do is to break it into chunks, right? So cosecant, again, is the inverse of sine. And so the first thing I do when I find my sine, and I'm going to use this space because I need every inch over here to do all of this work. So for the period of that, b is 1/2. So my period is 2 pi divided by 1/2. In other words, 4 pi. Okay, I'm stretched horizontally by a factor of 2. And I also have phase shift, right? So phase shift left pi. And then finally down 1. So the easiest thing to do, again, is to start with a sine of everything in the parentheses. So x over 2 plus pi. And then, of course, my x value here. So what happens at, well, let's just start on at 0, right? It's always the easiest thing to do. So if x is 0, this whole thing is 0, and I'm at pi. So pi is 180 degrees. Sine is my y value. So my value here at 0 should be 0. And then at pi, now normally my next flexion point would be pi over 2, but again, since I'm stretched by 4, remember I got 4 pi, so I'm going to divide that 4 pi. So I'm going to have 0, 4 pi. My halfway point between those would be 2 pi, and then halfway between that is pi and 3 pi. So those are the points that I'm going to use here. So this is going to be pi, 2 pi, 3, and 4. All right, that gives me a full period. At pi, this becomes pi over 2 plus pi, which makes it 3 pi over 2. And 3 pi over 2, that makes this -1. Back to 0, +1, and then back to 0 again. Now, I am stretching this by 2, so we're going to do the times 2 now. So I'm still at 0, but now it's -2, 0, +2, and 0. So that's this part. And then finally, shift down 1, so -1. So each of these points here is -1, -3, -1, +1, and -1. My cosecant starts, right, my undefined points are where my original sine was 0. So I'm undefined here, here, and here. And then fill in the gaps in here. So this is -3 and +1. So putting in my asymptotes, good, I got those right. And let's label them based off what I have here. So this point again is 0. And then this is my next asymptote occurs at 2 pi and then 4 pi. So halfway between here is pi, and this is 3 pi over 2. And so at 0, I'm at -1. Let's call this, well, I'm going to have to use all of these. So this is -1, -2, -3. Okay, so at 0, I'm at -1. And then at pi, I'm at -3. Back to -1, up to +1, back down to 1 again. So 1 kind of -1 here is kind of is what we call it the midline, right? This is where, because I've shifted everything, where it used to be 0 is now shifted down 1. So this graph is going to look like this. And remember, I start going down first because I phase shifted to the right. All right. Okay. Then, so my cosecant now starts at those max and min points and goes down from there. So I'm down here. And going up this way. Okay, so just recap what I did here. The first thing I did was I recognized that this is a sine function. It's the inverse of the sine function. I found my period, my phase, and any other transformations that I have here. I plot out the sine plus whatever was in the parentheses. I did my stretch transformation and then my vertical transformation. I could have done this all at once, but I break it down